Welcome to the lecture on mathematical statistics. In this lecture, we try to understand what statistics is all about and how you can turn your data into insights, how you can understand the variation, and how you can make better decisions with the help of statistical ideas. We begin with the question, what is statistics? When we want to learn about something, we first collect the observations, which are referred to as data. Then statistics is the science of dealing with the data, including the process of collecting the data, processing it, analyzing it, and also try to make some interpretations from the data. So these all the things are done under the branch of statistics. In short, if we say what statistics is, it's an art of learning from data. Why do we call it an art? If we give a data set to two persons, person A and person B, both the person will analyze the data in their own way. They come up with their own understanding and conclusions about a particular thing. So in that sense, it is an art. The statistical ideas allows us to gain new insights into the behavior of many phenomena. Statistical concepts and methods are not only useful, but they are indispensable, and they also help us in understanding the world around us. They allow us to turn the observational evidences into information which are useful for making decisions. So it includes a diversified set of tasks. It includes the experimentation, collecting data, processing, and making decisions. So consider the tasks of calculating the average downtime of computers. You're measuring the downtime of computer and then trying to give a one number summary of the data, which is an average here. Another case, you are trying to measure the amount of lead present in the tap water samples collected at different locations. So you are trying to make decisions whether the amount of lead is below or above threshold. So whether it is, so here you are doing the quality control. Sometimes you measure number of, you are trying to make attendance, you try to measure the number of persons, counting the number of persons attending a particular seminar on solar energy. You are making the data, you're collecting the data summary. So everything here we are doing statistically. Statistics is mainly about numbers and figures, so it comes under the branch as a branch of mathematics. However, statistics is different than other branches of mathematics. In what sense? It takes into account the presence of randomness or disturbances, sometimes uncertainty or variation in the processes. So there are noise, disturbances present in the real world processes. So all those things are taken into account by statistics. This makes it different than usual mathematics. Sometimes it is difficult to digest statistical ideas due to the reason, the presence of randomness in the processes. Suppose that we are collecting the downtime of computers and it comes out to be a same number every time you measure the downtime. You trying to measure the lead content in different water samples at different locations, but it comes out to be the same number. You're counting the number of people attending the seminar and it comes out to be the same number. So in this case, there is no need to deal with the heavy statistics. A single observation is enough to make decisions. So there is no randomness associated with this process, though no variation during the observations. We can skip the statistical ideas here and go with just one single observation. So statistics allows us to describe, understand, and control the variability, the change or the variation in the data, and it also takes into account the uncertainty associated with the processes. For what? So these things are the real life situations, and this helps us to make better decisions. We consider here an example of cloud seeding. What is cloud seeding? Cloud seeding is a process of spraying the chemicals over the clouds so that there is more rainfall or snowfall. So silver iodide in this case is sprayed over the clouds, and the amount of rainfall or snow is measured over an area, and then we try to answer this question: does cloud seeding works? Here we are dealing with the substance of silver iodide. What if you take different substance? Does it work in that scenario? So it's a research question. So how do we try to answer this question? We try to make observations, we collect the data, so we do the experiments, we measure that, collect that, then present that data. So here we have the data. We have the cases of unseeded clouds and seeded clouds. So this is our data. It is in terms of acre feet or feet. So amount of rainfall, precipitation measured in over a particular area. We collected total 52 clouds, and 26 or half of them were chosen at random, and the cloud seeding was done. Does the cloud seeding works or not? We try to see from the data. If we look at the graphical representation of the data, we present the data side by side for the case of seeded and unseeded, and we see the seeded. For the seeded case, some observations are extreme. And we try to get a numerical representation or numerical summary of this data, which is the average. So average precipitation in terms when the cloud seeding was done, and average precipitation when the cloud seeding was not done. And we are describing the data in terms of just numbers. So this is doing the descriptive statistics here. From graphical representation to descriptive statistics. At first, it seems like the cloud seeding works, but from looking at the average, looking at the graphs, it seems like the number comes out to be 441.98 for the case of seeded, and for unseeded case, it comes out to be 164.58. Should we conclude that the cloud seeding actually works? You have to be careful about few things. You have to be careful about the numerical summary which you are presenting. Here we are presenting the average, which is sometimes not a good measure to present when there is outliers present in the data. We also need to take into account the effect of randomness. What if the clouds you selected were the clouds which were going to give you the more rainfall, irrespective whether you do cloud seeding or not? So there is the possibility, the chance associated with this thing. We need to take into account this thing. And we also need to be careful about generalizing these things. And if we generalize this, like the cloud seeding from average, it works or not. What about the future clouds? And what if our decision is wrong? What is the risk, amount of risk associated with our decision? We try to do these inferences from the data. So this comes under the inferential statistics. We also try to measure the risks associated with our decisions, good or bad, how good and what is the probability or possibility of these risks. So there is the concept of probability, which is required to deal with the statistical ideas or statistical conclusions. We still haven't answered our question whether we should generalize this thing for the case of silver iodide or not. We leave it to your understanding. When you have more statistical understanding, you will be able to answer this question by yourself, whether we should rely on this numerical summary, graphical representation, and how risky is it to generalize this idea. Thank you for watching.